So I got a package here from the UK. This is from Hemingway Kits, Projects for the Engineering Workshop. All right, so I thought I would try my hand at this. Thought I would do this. This is for a tailstock die holder. It won't look exactly like this. This is an old picture, apparently. I think that's a better picture of it. This is milled out of a piece of flat stock here. So they give you a good set of plans. And some instructions. I mean, instructions, seem reasonable. All right, so this is instructions for milling the handle, basically. This is a die holder to hold smaller dies. The setup allows for 2 different size dies to be held, and they do give you the dimensions for the standard dies. And dimensions here are both in, looks like both metric and imperial. All right, so the first thing we're going to make is this piece, this cone. There's 2 of them to be made. It's got a 30-degree angle on the cone. There'll be 2 of these, and if you can see you probably can't see in the picture here, but these 2 cones interface with the male cones. Be 2 female cones interface with 2 male cones. Act like a clutch mechanism. The handle actuates them like a clutch. So they will spin with the work piece unless you use the pressure on the handle to engage these 2 faces and cause the die to stop, which then, when the die stops and the workpiece is still spinning, the die will cut threads on it. And then you can also do it in reverse. Okay, so we're going to cut these 2 cones first, and they give you the necessary pieces of material here. So we got these 2, I believe that's the right 2. They're supposed to start out at 1 3/4 inches. Just over 1.75, 1.751. This feels, rubs slightly right there. So that's pretty close to the nominal or stated diameter. So we'll go ahead and go over to the lathe, and we'll face these both sides. Got to face them off to a particular thickness, which is 20.6 millimeters or 0.813 inches, and then we'll bore it and taper the sides, create the cones. So we're going to have to do 2 identical cones. All right. So just chuck this blank in the lathe here. Just put it in my 3-jaw chuck. Given the repeatability and accuracy of this chuck on this lathe, which is a couple of tenths, I'm going to use the 3-jaw, even though the instructions say to use a 4-jaw and center it. I think I'm here. I just put it in the chuck, and I'm within 1/1000th of an inch, easy. Let me see if I'm here to the 0. It's a 1/1000th. I'm going to go with that. That's plenty good. Alright, let's just see where we are. Should have 33 thousandths to go. Alright, 0.846. We're going to 0.813. So that's 33 thousandths. .813 and 5/10. So that's good. So the task here is to bore this to approximately 1 inch. Now the exact measurement isn't critical. The instructions say as long as both bores are the same, then you'll be fine. So that's a nice smooth finish. I like that. Okay, let's do one more. We should be just a few thousandths left to go. That's 0.991. Got a nice finish inside there. All right, our plug gauge, it's actually 0.999, so I'm at 0.995. Got 4 thousandths to come off of the diameter. Okay. That's it. We'll take a series of passes on this. So let's get started. Bump the speed up just a little. Let's go to 510. See how that does. Okay, that's a nice finish, and this area back here is supposed to be 0.187. Let's check the other one up and do the same thing. So we just finished turning these two of these cones. Now we haven't cut the slot in the other side. We'll do that later. Next step is to cut this cone. It has a die holder on one end, and then we'll come back and cut this one, and then we have one more, this one up here, adapter. These are the two dies that I plan to use with this. So since this is hex, I have to cut the circular opening a little bit larger. This is a 1 inch, and this is, if I recall correctly, 1.15. So this will be my large die adapter, which would be on this one, and this is the 1 inch one that I will cut on this one. I'm not sure if I even need to make this small die adapter. I may go ahead and make it, but I don't have any dies small that would fit that. I think they're 5/8 inch diameter. So for the time being, these are the two dies that I would normally be using. This is from my old Craftsman set, and this is a newly purchased one from McMaster. This may even be, I'm not sure, this might be reverse thread. So in any case, that's what I'm working on. This is the next task. All right, I'm cutting this down to 1 7/16 or 1.4375 or 1.71. All right, we're going to take about 1/4 of an inch off to begin with. .43. That's good. All right, we need to drill, bore, and ream to 5/8 of an inch. Just knocking the sharp edges off of those two corners. Okay, we'll turn around the chuck. Just wanted to clean up that. We need to put an indicator on here and turn it, set it concentric with the bore. All right, so I've got the bore set up with the test indicator here, and there's a little, it's measuring some roughness on the inside of the bore, but it is basically within 1/2 thou or so here. So I'm going to call that good. All right, 1.27, 1.275. Here's where it pays not to have a screw-on chuck. We're going to cut off the back sides, be running counterclockwise. It's the only way I can get or it's the easiest way to get the taper on here using the boring bar. So we'll tighten that down. We're going to run in reverse this time. Okay, we're there. And that's nice. .826. Yeah, it looks like .826. We're hit it right on the money. All right, that's a counter bore to start the thread. Okay, that's 24. All right, I think we're done with that. We're getting close here. Oh, there we are. Okay. The plans have us drill several holes for grub screws or set screws to hold the die in place. I'm going to do that at the mill. All right, I think we're done with this component. I was actually supposed to cut this recess for the die before we turned it around and cut the cone, but it doesn't matter. I went ahead and chucked it back, centered it, you know, using an indicator so that we could cut this true. So looks like we're done with this part. All right, so I cleaned the threads out a little bit. So it's a reasonably good threads. I did create one little flaw in one of the early passes, like the second pass. I stopped too soon. So there's some marks on the threads, but the remaining passes stopped at the correct depth. So I think they're going to be fine. I don't see any, even though there's a flaw in the thread, it isn't all the way to the bottom of the thread, isn't the full thread depth. So I'm one of my first attempts at internal threads. Not too bad, especially for such a fine pitch, 26 threads per inch. 7/8 by 26 is what this is. Die holder. Those of you that are machinists will probably have noticed that I had my compound set at the wrong angle for cutting the threads. That is, set at 60 degrees instead of 30 degrees. I had to set it at 60 degrees to cut the cones. I have one more cone to cut, so I didn't want to change the compound angle. So I cut the threads just, I don't know what you call it, just pulling the cutter directly into the work so that the 60 degree cutter went into the work at a 90 degree angle instead of at a 60 degree angle. Now, it's not the best way to cut threads, but it is an optional way. Since it's a small thread, small pitch, or large pitch, 26 threads per inch, I felt like I could do that. Save me from having to risk having a different angle on the next component, which also has a cone on it that needs to match. So the cones have to be identical to be a reasonable clutch. So far, the cones I've done, the one male and the two female, are perfect. I mean, they fit. There's no slop in them. They are a good match. I didn't want to risk changing the compound in order to back to 30 degrees so I could cut the internal threads the way you would normally cut them. So I risked that by cutting them at a 90 degree angle. Hopefully that will not prove to be a big mistake. We'll find out here before too long. All right, we've got these two parts completed. We're going to move on to this part, which is a large die holder. Got the dimensions here. So we'll chuck the piece of stock and face it off, bore the opening here for the die, and then turn it around and work on this end. So we'll turn it down, and then we'll cut this taper. Now this cone has got to be the same angle as these two. Now I have not moved the compound since I did the taper on this cone and the taper on this cone. So the three cones will all match. So two of these female cones interface with these two male cones. So they'll all be cut at the exact same angle. All right, so we'll work on this one. .105. All right, so that was 9/16 drill bit. Need to ream it to 5/8. This is a 5/8 inch reamer. Next step is to turn this down to 1 inch, the final dimension, using these cones, the first part we made as a gauge. So we want this to be a good fit on here. So let's take a measurement of this. My battery went dead in the camera without telling me. All right, my target was 0.875, and that's where I am, 0.875 and 4/10. Okay, good enough. All right, I turned the thread on here. I got a little impatient and took off a heavier cut than I should have, so the threads look like crap. But I think everything fits as intended. So I'm happy with that. Everything fits as it should. So we still don't have, there's a 5/8 inch shaft which goes in here, and then we need to turn the threads on the arbor as to hold it, the Morse taper arbor in the tailstock. But I think what we're going to do is I'm going to wrap it up at this point. Gotten this far. I don't want the videos to get too long, but this, you know, these 4 parts, while the thread's pretty ugly on this one male part, I think I didn't cut the threads. I cut them to spec, but I didn't cut them deep enough on the female side. So I wound up having to cut these threads deeper than spec, or in order to get the diameter down enough to fit in the female threads. But they're certainly engaged properly. There's plenty of threads to hold it, so strength's not an issue, it's just appearance. So I'm not very experienced with turning threads, single point turning of threads, but I'm learning. So, okay. I think we're going to take a break. All right, folks, that's going to wrap up this video. Don't want to get these videos too long. We'll come back next time, continuing to work on this die holder, tailstock die holder. If you have any comments or suggestions, I would be all ears. This is one of the few times I've actually had a project where I've had a drawing and dimensions to meet, which is, I mean, you machinists do it all the time. Like I said, I'm still learning this lathe, which is one thing. Looking at the drawings make sense. I don't have any issue understanding the drawings or applying them to the material. It's not overshooting the dimension, for example, being able to take measurements and take the right depth of cut in order to, you know, achieve the desired dimension. That takes experience. I'm learning. I'm getting real close on all the dimensions here. Haven't had any major mishap. They all are to dimension within a thousandth, certainly. I think I'm in pretty good shape there. All right, thanks for watching. Leave me a comment. Tell me what you think so far. We'll see you next week.